Hi, welcome to Agastya Software Technologies MicroService Series. In this series, we are going to elaborate what are the microservices principles, what is a microservice, where these microservices are feasible to implement, and the pros and cons, and what are the microservice technology enabling platforms, other technologies. After the theory part, also we will discuss implementing microservices using Spring Boot and JEE. Why microservices here? So the first we can see this one. It is all about managing and reducing the risk for business. These microservices enable to manage efficiently and reducing the risk for business. How it is works in managing and reducing risk. When you case why microservices, see this is the first point, business meaningful capabilities. All the microservices are built around business capabilities. We'll elaborate later. Second is become agile. When you want to move to agile, then this become agile, and it reduces when you're moving from monolithic to microservices. It reduces the complexity, and we are going to partition the system. Like if we see this system, and when we converting into microservices, the system is partitioned into smaller components and federated teams, and greater availability and scalability. When we have this big system, when we partition this one in this system, only this component is accessed more times. So if we want to scale, instead of scaling all the components, if it is lying here, then we have to scale the whole system. But here only we will scale this component. So the scaling stability also we will focus on the scalability. And one more important thing is development language lock-in, polyglot. Again, this is unlocks experimental learning capabilities on organization level, which is not at all possible with the monolithic. So this is the very important for the business. If the business always, the business changes, they go for a new experiments. Whenever they want to go for new experiments and learning from those experiments with the minimal costs, with the minimum costs, it can be done with the microservices. With the monolithic, it is quite impossible. We can do it, but it is quite impossible. We can't. That learning and experimenting is not that quick compared to microservices. So these are the reasons why microservices means business meaning capabilities. All the microservices are done as around the business. I can become agile, reduce complexity, and we're going to partition the system. We will discuss what are the benefits we're going to get by partitioning the system, and the federated teams, greater availability, stability, and scalability, and polyglot development language lock-in. Again, for experimenting and learnings, this is the best way. So this is what, when we can say in nutshell, we are all doing to support the business. So it is all about managing and reducing the risk for the business. What are microservices? Let's elaborate about the microservices. We can see what this microservice means. It is a style, is an architectural style. If we see here, it is not a framework, it is not a software, It is not a framework. It is like one type of discipline, an architectural discipline that's structuring an application, a collection of autonomous services. And also important is these are modeled around business domain. What does it mean? If we elaborate more, when we have a business domain like transactions, so if in a banking sector, when we are doing transactions, if we consider as a domain, in this one we are modeling all the microservices related to this domain like this. So these are modeled around the domain. We are monolithic application. We are dividing into small autonomous services based on this discipline, based on the architectural style or discipline. Just is a discipline. Previously, before this discipline, we have a monolithic big application. Because of this monolithic application, what the main problems is the business. These days, business is the changes in the business are rapid. Because of the competition, all the business, like the strategies of the business changes every day. To support the business means for the business to experiment and also to make the decisions based on the experiments. So we need to support the business in a very quick, in the rapid way of developing the softwares. So to develop the softwares with the minimal costs and in the very jet rocket speed, put it that way. So that's what these microservices are popular these days. Now we can see, as we discussed in the earlier slide, these microservices are modeled around the business domain. You can't combine two business domains microservices together. That is not the style of this architectural pattern. So according to that architectural pattern, so we have to model around the business domain, So all the microservices of this business domain group put together. These microservices are the main characteristic of this one is autonomous services. Autonomous services. That is very important. And also these microservices are independent, autonomous, so that we can scale independently. That is very important. Also the stability and the scalability, these are the two important characteristics we are going to achieve of the microservices. Now we can see here the monolithic before microservices. Means again I'm stressing the microservices is like a pattern, is like a style, is a pattern or a style the software development is following. This is architectural pattern. So before that, one big monolithic, like we can see these number of microservices. And again, there are pros and cons. These days, I observed that people are talking about microservices. If we are not modeling these microservices around the business domain, there are many consequences. If you are modeling around your technology, that's what we are going to elaborate more on, what the observations I also made in the industry. Some of the people they're talking about microservices to enable the IT development. No, that is not the case, to enable the business domain. So we'll elaborate the differences between the way the reusable components in the IT development, also they're developing the microservice. There is a danger of that, of the maintainability. We are going to more elaborate these patterns in our practical session. And again, this microservice architecture, each service, this is important, each service is self-contained and implements a single business capability. Self-contained, autonomous, and also need to implement a single business capability. Now, if we see the architectural differences before microservices architectural style, now we can see is a monolithic. In this monolithic, the components like customer service and product service and cart service, and this is the UI. Okay, this is what we are doing all these into one. If we see this one, all these components are together into one big application. Because of this one, if we want to scale the cart service, we can't scale. We have to scale the whole application because all these is tightly coupled into a single application. We can't scale these ones. And also some enhancements to be done here. We can't done independently because this is the part of the application. So all these are, now we can see the architectural diagram pattern. This one, now the customer microservice is autonomous. So here it is not autonomous. They are in this big block. Now this is autonomous, and the product service is autonomous. This is autonomous. They can communicate each other. And now this UI is built based on the microservices. Because of this architecture, we can scale independently and changes independently, deployments independently. When we're doing the cart service, there's no impact on product and customer service. If you want to scale only the cart service, we can scale. So we are slicing down. Just we can see this one is a big block. We sliced, but when we sliced, this is what the style is important. When you sliced, you have to slice very carefully. These are self-contained. This is very important. Self-contained, autonomous. That is very important to be followed. Now we are going to some of the comments by the one who introduced these microservices, Martin. So when we're discussing his comments, the first one is important. Microservice architectural style is an approach in developing a single application as suitable of small services, each running in its own process, communicating with the lightweight mechanism, often HTTP. So when we dividing the app like this, small independent services and lightweight communicating over HTTP. This is the first one. Second one, these services are built around the business capability. This is what we are going to elaborate in our practical session. That's what one of the observation I made. They are also making IT capabilities. That's what we're going to discuss. These need to be modeled around the business capabilities. Independently deployable by fully automated deployment strategy. So when we do CI and CD, each one, like is a product service and a cart service, then account service, each one need to be auto deployable, independent deployable. And again, there is a bare minimum centralized management of these services. Each one may be written in different polyglot. So this one is written in C++, this is in Java, this is in different language. Each one It doesn't matter what language are using, and again what storage. Here we're gonna using MySQL for product service. For cart service we are using Oracle, and for account service we are using and some any database, any NoSQL databases we're gonna go for. We're gonna Postgres. We're gonna go for either Postgres, like the different storages. It need to support. It need to support different storages, different technology. Each one is deployable on its own. So these are the some of these are very important comments the Martin mentioned when we are following this architectural design pattern. So now we see that each microservice is different, and you see these are microservices are completely different, but the important point here to notice is they share the common characteristics. So when they say they share the common characteristics, what are those characteristics? So the first one is single responsibility. That is very important. When we model the microservice for a business domain, each microservice need to only responsible for single responsibility. And self-containment. These are completely need to be independent, autonomous, self-contained. And service independence. So each service need to be completely independent so that it can be scaled. If you have any dependency, then this is completely not possible. Self-independence. Highly decoupled, completely autonomous, and highly resilient. So these are the very important characteristics these microservices share. All these are different, but these share these key characteristics. Now this is the we coming to the design aspect, how we need to design. When we design here, when we see this microservice architecture, the microservice architecture have their own load balancer and execution environment to execute their functionalities, and at the same time to capture the data in their own databases. So completely each microservice, they have their own load balancer and own execution environment. Completely this execution environment of B is different from A, and the C is different from B, and D is different from C, and each one has its own gateways. And also the storage is completely independent. The storage for microservices A is not the same as B, not the same as C and D. And all the microservices need to communicate, this is important, through a stateless server. So this is when this need to happen when the microservice A want to communicate with the B, or A want to communicate with the C, or B need to communicate with the D. They need to go through message bus, any MOM oriented service, or by using HTTP REST. So this is very important. Then all the functionalities performed by the microservices communicated to the client. So if any client, so these are internal communication need to happen through message bus or HTTP REST. Here there is no gateways involved, but any client here, whenever any client need to interact, they need to come with the API gateway. API gateway. This is the design. Now the question, the considerations, the granularity, what is the size? When we say micro, this is not the size of the software, means the lines of code. Micro means micro business function. This is very important. So don't confuse. Micro means is not a small component of the sub project. No, it doesn't mean that. Micro means a small business function. Small. What is the smallest when we have a business? Okay, we will discuss in the next slide how we going to go for what is the granularity question. We'll discuss in the coming session. Sorry, in the coming slide. And service proliferation, maintainability. This is very important. If we go for too many microservices without understanding business and architectural pattern, then the maintainability becomes nightmare. And end-to-end responsibility and the security and identity access. So this is all about common sense and practicality. So the organization need to mature in using this architectural pattern. And Conway's law, so any organization that designs a system will inevitably produce a design whose structure is the copy of organization communication structure. So whenever organization communication structure, then the software design need to be a reflection, of that. It need to reflect. So the organization communication need to reflect by the system. Then only the business functions properly. Now, this is what we're going to say. This is when we say one organization. In organization, we're going to have different business units. We're taking one business unit. In this business unit, we have different business functions. Business function 1, business function 2, business function 3. So one organization is divided into business units. Each business unit is divided into business functions. So around this business function, we going to develop the microservices. All the microservices need to target the business function. This is the target. So this business function comes under business unit. So this is what the streamline and agile software cycle team organized around business domains. This is very, very important. And ownership empowerment of DevOps means when we develop microservice need to be auto deployable, continuous CD and CI, and reduced capital expenditure and operational expenditure, CapEx, OpEx. Scale where is needed. This is very important. Where it is not possible with the monolithic. Now, previously we discussed about the characteristics. Now these are the supported characteristics. Decentralized data management, implementation agnostic, scalability, stability through parallelism, stable contract APIs, REST APIs, point-to-point integration, federated autonomous governance, single team end-to-end responsibility, and monitoring and instrumentation enabled. So these are the supporting characteristics. Now we are going to discuss the building blocks. When you see the platform here, then on that the framework and the microservice here, any framework we can use in the case of developing microservices and platforms also we will discuss in the next session. Now we will see what are the enabling platform components and monitoring, automation, cloud deployments, container technology. You go for any container technology, Kubernetes, service discovery, lightweight messaging, and API gateways. So these are the platform components which is supporting microservices architectural style. And enabling technologies, Docker, Kubernetes, Node.js, Apache Zookeeper, Swagger, Consul, HA Proxy, Kong, Spring Boot, Akka. So these are the enabling technology and ecosystem. The challenges, especially in the microservices, is the granularity. So when we have organization, business unit, business function, so this business function, how granular you're going to divide. So this business, so when you are modeling the microservices around your business function, again, business domain, which is business unit, you need to be very careful of the granularity. So this one need to be more like self-contained, autonomous. All these you have to take in consideration. And chattiness and fanouts, payload serialization and testing, microservices, governance, so dependency management and service. So the main thing is if we are not following this pattern, there are too many headaches of too many microservices, maintainability, and that's what we need to be more careful when we're talking about microservice. Micro means it's not a small. Micro means you need to use in terms of the business. What is the smallest business function we can implement? Micro. From this we can't divide. We can't slice that. So that is what the granularity comes into the picture. So now if we see this one in this the main is now if we here in organization, if we go old traditional way, monolithic, and you can go for a nano, you can see too many microservices, and you can see the line of granularity here. So you need to be from nano services, you go to monolithic. So you need to be more of an art than science. This is not a science. This is not a technology. This is just as a discipline. Is an art. It is a common sense to be followed. So there is a reason. Each organization, if two organizations are following microservice pattern, one is doing better and another is not doing better because of the maturity level. Because this is not a software to be used. It is an art than a science. So this is so when organization is maturing, they can see the results of following this pattern. Consider business flexibility and agility needs. This is the why all these microservices are coming into the picture for business flexibility and agility needs. Behavior of monolithic and nano. If you go up, you end up in the monolithic. If you go down and nano, so you need to have a balance line of granularity. You have to have a balance of discipline. This is very important. And this is the end of the first session of the introduction. In the next session, we'll elaborate more. Once we're done with the theory, then we will take the practical example. We'll start the implementations of the concepts which we are discussing in the theoretical part.